PNDA, an open source platform for network data analytics. We're all told how much information is flowing around in the world, and those numbers keep increasing year over year. As we see more and more sensors streaming more and more data, and the amount of data rising by these numbers, the question is, what can we actually see? What are the insights that we can actually get from the data? When we start to bring the network as a data source and apply big data analytics to it, what are the questions that we can start to ask? PNDA is an open source project under the Linux Foundation, providing you with an ability to deploy an analytics platform built from best-of-breed open source packages. It can be integrated into your environment, ingesting a wide range of different data sources, and present those data sources to bespoke applications or off-the-shelf applications. A typical development lifecycle, starting from a Jupyter notebook and then working through to deployment of an application on top of the standard PNDA cluster, is a normal way for getting an application working. And we already have a number of partners who are working with us. Let's take a look at network data analytics in action. In this application, we're going to apply big data analytics techniques to BGP information, digging in using the open source project Streaming Network Analytics System in conjunction with PNDA. The deep analysis application is analyzing the updates that we're receiving through the SNAS application. Here we can see the top end ASs, including the number of prefixes that are being transited and the routes originated. We're then able to do a drill down, and here we're taking a particular AS of interest, to understand the particular behavior of this particular AS. So here we're seeing the fluctuations that have been observed in terms of prefix changes in the last 24 hours. And this graph just gives us a very simple visual representation of the changes that are occurring. Here we can see some of the prefixes that are transiting through or are being originated. And we're also able to represent the connectivity in this force-directed graph. Floating over the different ASs, we can see the number of prefixes being originated and those that are transiting. By comparison, taking a different AS, again, we can take a look at the observed change behavior over a 24-hour period. And here we see quite a different graph to that we saw previously with our other example. Again, taking a look at the connectivity, and here we can see a very, very densely connected AS. Very different to the one that we observed previously. We're now using the BGP AS path analysis tool. We're entering our source AS and our destination AS, and then we're going to see all of the observed paths that our system has been recording. We can now see the most recent updates. Here we can see the path length that's been observed, and then we can sort this information, looking at the shortest observed path and when that was first seen, and the longest paths that we've observed, including the padding or the AS prepending. We can take a look at a particularly interesting AS path. Here we can see the hop by hop, and this includes an AS that's prepending 15 times. The security audit module is looking for Martians and Bogon prefixes. These are RFC 1918 style prefixes, as well as prefixes which are currently formally unallocated. With our data looking back over a week, we can see the prefixes that have been advertised. And by using the filters, we can then pick a particular AS and even down to the particular prefix that we're interested in. With this selected, we can now drill in and look at the observed paths that we've seen over the period of time, and therefore we can understand how this has fluctuated. Here we can see that the AS path length has changed, and our graph here is plotting that path change as it fluctuates between a length of 6 and a length of 8. This particular unallocated prefix is being advertised by an AS in Bangladesh, and using our comparative view, we can see how that path has changed over time as it's being received hop by hop through to our particular peer. These paths can be sorted by time, length, and can be exported in either JSON or CSV format for additional analysis. Lastly, some work that's in prototype right now. We wanted to build on our security audit capabilities and look at the concepts around multi-origin AS and more specific prefix injections. For example, if we have an AS that's originating a prefix 100.100.00/18, a more specific prefix injection attack would be a hijacker originating a more specific prefix, for example 100.100.63/24. The issue is that you don't know that you're necessarily under attack at any particular point in time, and you may not be aware of the attack taking place, since if you have the appropriate security filters in place, the attack is happening to the traffic destined towards you, not necessarily to you as the target itself. With, in theory, any prefix in the internet being susceptible to a more specific prefix injection attack, this is very much a case of looking for the veritable needle in the haystack. Using the constant recording into the Panda platform and a Jupyter notebook to explore the data, we were able to build prototype code to look for and identify cases of multi-origin and sub-prefix injection attacks. This graph shows the number of BGP advertisements for prefixes being observed with multiple origin ASs within a 24-hour period. This graph shows the cases of sub-prefix injections being recorded. In particular, we're looking for those orange markers. These indicate sub-prefixes where the AS path is highly divergent from the original owner AS of that prefix. With all the information, we're then able to show not only who the victim ASs are, but also who the potential perpetrators are. With this ability to look at the information in near real time, we may be able to move towards a position where we can adapt, react, and respond to a range of different kinds of events.